Hey guys, welcome back to another complete walkthrough video, and this one we'll be looking to tackle the maths paper 3H, and this came all the way back in May 2018. Now these kind of papers are actually phased out, but they'll be really useful for your current spec, and I'm talking about spec as of 2020, and this is going to apply to 2021. Now without further ado, let's jump straight in, guys. And oh yeah, for all IGCSE Edexcel exams you can always use a calculator. So make sure you guys whip out a nice Casio one, because these are the best ones and highly recommended calculators to use in these papers. But other than that, let's move forward. So you could read instructions, but it's always necessary to know what kind of formulas you're given. You're always given Pythagoras and trigonometry, also some useful 3D shapes, the sine rule and cosine rule, as well as area of a triangle, and of course typical volume of prisms, so where you work out the area of its face and times it by its length. But yeah, without further ado, let's look at number one. So here it tells us to work out the value of this entire sum, and we have to write down all the figures on your calculator display. Alright, so this is quite easy if you're using your calculator correctly. My advice, if you're using a Casio calculator or anything similar, always start with a fraction button, and it looks a bit like this. Once you do this, you just copy all of the top part and the top half of the fraction, and copy the bottom half over here, and just press enter. So you want to make sure everything's in one place, and when you do that you should get a result that says something like this. So 231.19 and then ... So yeah, always write down pretty much everything you see in your calculator. Now for part B, it says give your answer to part A correct to 2 sig figs. Now what this means is that we just care about looking at the first two digits, so I'm talking about the 2 and the 3 part. Now if you look at this one, this means we always do the decider on the digit afterwards, in other words the third digit. So because 1 is less than 5, this means we round 231 to 230, so you round down. If it was 5 or more, we'll round a 3 up to a 4, and this would have become 240. In this case we stick with 230. Now let's go to number 2. So it says that the total cost of 8 calculators of the same type is £62.80. Work out the cost of 12 of these calculators. Alright, so what I would do personally is find the cost of one calculator. So to find one calculator, we're just going to do £62.80 and divide that by 8. And wherever this gives you, we're going to then multiply it by 12. So do this calculation first, times it by 12, and then you're going to get an answer of £94.20. And that's it. That's simply all you got to do. Now number 3. So Steve goes on a cycle ride. He cycles at a distance of 40 kilometers in 2 hours and 15 minutes. Oof. Work out his average speed in kilometers per hour. Alright, give your answer correct to the nearest whole number. Alright, so to work out any speed, distance, time equation, we should always know the formula. And the formula is always speed equals distance over time. In this case, they want it specifically in kilometers, which we got, and per hour, which we almost got. Now to convert 2 hours and 15 minutes into just hours, my little trick would be to write it like this. You got 2 hours, and to change 15 minutes, that's just 15 over 60, because we know there's always 60 minutes an hour. And when you put this in a calculator, you should get 2.25. So that's 2.25 hours. Therefore, the distance over time, well, we know he took 40 kilometers, so that'll be 40, and he took a time of 2.25 hours. And when you put that in, you should get an average speed of 18 kilometers per hour to the nearest whole number. Yeah? So make sure you round it up to 18. Yeah. Now next part. So here they're saying Steve's salary is $28,500. All right, decent. He gets a salary increase of 2.4%. Work out Steve's salary after the increase. Now for these kind of questions, there's a really nice formula to work with, and this is the one I use. I always look at the original value times it by some multiply, so 1 plus or minus a rate, and it'll give us a new value. Okay, in this case the old value, or the original value, is 28.5k, and the rate is going to be 2.4%, and because it's an increase, we're going to use the plus sign. So in other words, the OV is 28,500 times it by 1, the increase, and the rate will be 2.4%. Now if you're using a Casio, you could just write a percentage button, but if you're not, you got to rewrite this bit as 0.024, strictly in decimal form. And then when you do this, you should get a result of $29,184, yeah? So always try and keep the answer simple, yeah? Direct. It's better to be direct and quick. Okay, now last one. So Nalini gets a salary increase of 3%. Her salary increase is $702. Work out Nalini's salary before the increase. All right, so what it's saying here is that now 3% is actually equivalent to $702. Why? Is because it actually tells us that that's how much the increase was. Now to find out how much it was originally, well, my personal advice is to always find 100%, because 100% means original amount. Now to get 100%, there's a quick easy way to do it. Find 1%. To get 1%, just divide it by 3. So 702 divided by 3. You could work it out, you could just leave it like that. That's fine. And then to get the original amount, which is 100%, just times your result by 100. So 702 over 3, whatever that was, times 100. And in your calculator, you should get $23,400. And that's it. Okay, number 4. So A. Describe fully the single transformation that maps A onto B. Okay, so looking at these two shapes for a second, this looks to me like there's a reflection going on. But where is the mirror line? Now, if you're not using tracing paper or a mirror, my personal advice is to just pick a corner of A. Yeah? So let's say this one here, and pick like its reflective corner on shape B. Well, if this was this corner of A, it must be here, just by the way it looks, by symmetry. And I would measure the distance. So I'll just put a dotted line, and I'll count the blocks. Well, there's 4 blocks, and usually the mirror always has an equal distance. So it's going to be bang in the middle. This means the mirror line should be here. And yeah, I recommend you have a ruler, guys. So this would be the mirror line. Now, how do we describe this kind of transformation? Well, we would say that shape A is mapped to shape B using a reflection. So that's the first keyword on the x-axis, which is at x equals 6. On x equals 6. So that's it. This would be pretty much enough. You could say a reflection on the equation x equals 6, but yeah, that should cover it. Now B, on the grid, rotate shape A 180 degrees about 40. Okay, so 40, first things first, is over here. This is the coordinate. Now what they want us to do is somehow rotate this shape A across into this quadrant here. Again, to use a nice little trick, I would just measure distances. Let's start with this corner. If we're going 2 down here, this means if we reflect it 180 degrees, we should end up with a straight line. So it should be two blocks down as well. So this corner is now mapped over here. Likewise, for this one here, if I drew a straight line across, so let's just do a dotted line. Because it's 180 degrees, it's going to be another straight line. So it'll be somewhere over here. So again, the same distance is measured. Now you can kind of see that just by copying the shape, this line here is of course going to map over here, and you can see that this line over here will now map over here, and then you can kind of draw the rest of the shape. So I will now delete this part here and just kind of visually draw it. Because I drew these 2 lines here, this longer line, which is 4 lines down, should be over here, 4 lines down, and then finish the shape. This corner to that corner, and you're done. All right, number 5, yeah. So here is a biased 5-sided spinner. Okay, so it's biased, meaning not all things are the same. Yeah. Now Jack spins the spinner once. The table shows information about the probabilities that the spinner lands on red, blue, black, white, or green. Okay, so they kept it algebraically. Now work out the probability that the spinner lands on red. Now, first things first, for probability, always make sure you add all of these and they have to sum up to 1, right? So x plus 2x plus 3x and so on, all sums up to 1. So therefore, just adding all these x's up, you got x plus x plus x, that's 3x, plus another 3x is 6x, plus 2x is 8x. So 8x must equal 1. And then solving for x, well, x must be 1 over a. Now looking at this question, work out the probability that the spin lands on red. Well, to land on red, it has a probability of x. Because x equals 1 over a, therefore, the probability of red is therefore 1 over a. Okay, that's that one done. Oh, you get 3 marks for that. Whoa. Now Malia spins the spinner, damn, I hate these alliterations, 200 times. Work out an estimate for the number of times the spinner lands on black. Okay, so first things first, what's the probability landing on black? It's 3x. We know the probability of x is 1 over 8, so 3x must be 3 over 8. So we can say, alright, it's going to be, probability will be 3 over 8. Because she's doing it 200 times, just multiply this by 200. And then you just put that in your calculator. And when you do that, you should get an answer of 75. That's it. This is literally, in my opinion, easy 5 marks bagged. Alright, number 6. So A, factorize m squared plus 7m. Well, to factorize, you just look at the common term in both. Since they both have an m, we can divide both of these out by m. And then when you divide them by m, well, you just left with a single m for this one. And divide 7m by m, you just left with a 7. And that's it. This is literally your answer. So that goes here. Now B, solve this equation here and show clear algebraic working. Alright, so what I would do, when you got brackets, always expand it, yeah? So times 7 across, you're going to get 7x plus 7 times 3 is just 21. Copy the rest. And now to solve any equations, always move all the x terms to the same side of the x and the non-x terms like 21 with the number terms. So to move 5x across, since it's positive here, we need to minus 5x across. So 7x take away 5x is 2x. To move 21 across, we need to minus 21. So minus 4 minus 21 is minus 25. And now this part is easy. You got 2x, to get just x, divide by 2. So therefore x equals minus 25 over 2, which is minus 12.5. And that's it. Expand and simplify this double bracket. Nice easy trick here, guys. Just draw some arrows. So all we want to do is y times y times minus 4, 9 times y, and 9 times minus 4. When you do that, well, y times y is y squared, y times minus 4 is minus 4y, 9 times y is plus 9y, and 9 times minus 4 is minus 36. And then you just collect the like terms. And you just have to look at minus 4y and plus 9y. Combine these two, you get plus 5y. And therefore, we put the answer here. Our solution will be y squared plus 5y minus 36. Alright, so I'm really liking these questions so far. They're not too bad. Now D, simplify this thing here. Ooh. Alright, so there's a super easy trick to this. If all of this is powered by something, just stick power 3 to all these terms. So in this case, you've got 4 to the power 3. Because you've got power 3 already, it'll be 3 times 3, which is 9. F power 2, because you've got power, there'll be 2 times 3, which is 6. And this would be your answer. But all you got to do now is put 4 to the power 3 in your calculator, and that should give you 64. So your final result will be 64 e to the power 9, f to the power of 6. And that's it, guys. All done. And as always, guys, if you're really enjoying these videos, please give me a like so that way YouTube will configure its algorithms to put my videos on the search bar. And if you want to see more of this, share it with your friends and subscribe. So calculate the length of HJ, so this unknown one, which we can just call X. So always give lengths a name. Give your answer correct to 3 significant figures. Okay, guys, so first things first here. When you see a right angle triangle, always think 2 things. 1, Pythagoras' theorem, or 2, SOHCAHTOA. Well, you only use SOHCAHTOA if there's angles involved. So in this case, we're going to use Pythagoras' theorem. Now, what's Pythagoras' theorem again? Well, he states that a squared plus b squared must equal c squared. In other words, the squares of 2 lengths must equal the hypotenuse squared. In this case, the only hypotenuse is 16.2. So that's going to be our c. This means that a and b could be anything. So a could be this one and b could be the other side. Now, putting this into the formula, well, a squared plus b squared, this is essentially 11.8 squared plus x squared must equal 16.2 squared. And this is straightforward now. All you got to do is just rearrange, make x a subject here. Now, what I will do is subtract 11.8 squared across. So we're going to have x squared equals 16.2 squared minus 11.8 squared. Put this all in the calculator exactly as you see it. And then square root your answer. And when you do that, guys, you should get a result, three significant figures of 11.1 centimeters. And that's it, guys. That's this one done. Number 8. All right, so solve the inequality. All right, not too bad. To solve literally any single type of equation or inequality, you always got to make x a subject. And well, the only way to remove this is to subtract 4 on both sides, okay? That's how you get rid of plus 4. And doing so, well, you'll be left with x in the middle. Now subtracting 4 across, 9 take away 4 is 5, minus 3 take away 4 is minus 7. And that's it, guys. Literally 2 marks for that bit. For B, on the number line, represent this inequality. Alright, so let's forget about the signs for a second, yeah? This means y is between minus 2 and 5, yeah? So what I would do, just draw a circle of minus 2, draw a circle of 5, and connect them, yeah, with a straight line. So you could use a ruler for this or something. And now, what you got to notice here is that one has a little equal sign attached to it. So this is less than equal. The other one is just a less than. The one with the equal sign means you include 5. So this means you got to shade in the 5. If you don't include it, then you do not shade in. So that's it. That's literally 4 marks for this. Now, number 9. Write 82 million in standard form. Now, the easiest way to do stuff in standard form is to just always put an arrow on the very first digit, which is the 8, and then write a point and copy out every non-zero digit. So the only other non-zero digit is a 2, so it'll be 8.2. And then we write times 10 to the power something. Well, how to figure that power out? You just count how many digits are after the 8. Well, you got 3 zeros, another 3 zeros, and a 2. That's 7 digits, so it'll be 10 to the power 7. And again, that's done. For B, write 2.9 times 10 to the power minus 5 as an ordinary number. Well, an ordinary number is literally these kind of types, just your everyday numbers. Now, if you've got a negative power, this just tells you how many zeros are before the first digit 2. Well, you got 5, so this means 5 zeros. So what I would do, I'd write 5 zeros like this, and then put a 2.9. And I always put decimal place over here. You always put decimal place just between the first 2, right after. So this reads as 0.00029. And again, always put your answer there, yeah? Alright, so next bit. So according to this information, Jupiter has a mass of 1.898 times 10 to the power 27 kg. So that's a lot, by the way. That's heavy. Mercury has a mass of this amount, which is actually less. So don't look at the figures in front. Look at the 10 to the power ones, yeah? This is 10 to the power 27. This is 10 to the power 23. This essentially has 4 more digits after that one. So this is way bigger. Now, the mass of Jupiter is K times the mass of Mercury. So in English, you can say, let's say the mass of Jupiter is J. That equals K times the mass of Mercury. So K times M. C, work out the value of K. Well, just make K a subject. So divide M across. You're going to have J over M, which must equal K. So the mass of J over the mass of Mercury. Give your answer to 2 sig figs. Well, we literally just said what we have to do. So just put in. So in your calculator, guys, I want you to write this. The mass of Jupiter, which is 1.898 times 10 to the power 27. All at once here on the top half, and on the bottom half of the fraction, 3.285 times 10 to the power 23. And when you do this, you should get an answer, well, to 2 significant figures. Actually, wait, in your calculator, you'll probably get something like 5777.777 and so on. Because they want 2 significant figures, all you got to do is highlight the first 2 numbers and look at the decider, which is this value here. Since 7 is bigger than 5, this means you round this number by 1. So then it becomes 5,800 or 5,800 times bigger. Alright, number 10. So here the table shows information about the weight of 60 apples. Okay, so for every single kind of tabular looking question, when you got tables and stuff, the frequency means how many. So for example, we know we got 60 apples, so all of these frequencies should total up to 60. And for each information, for example, they say 12 of the apples must weigh between 160 and 164 grams. Whereas let's say just 3 apples weigh between 180 and 184 grams. So yeah, so this is just classifying data. Okay, so looking at part A, they want us to write down the modal class. And well, the modal class is just another word for saying the mode, guys, yeah? So just find the mode. Now, if you're not sure what the mode is just the most common. And to find the most common in frequency tables, just look at the one with the highest frequency, guys. So this is the mode, yeah? That means the mode with the highest frequency is the class apples that weigh. So you can write this answer, 164 to 168 grams, because most of the apples weigh somewhere between there. Now part B, work out an estimate for the total weight of 60 apples. All right, so this is kind of like finding the mean. Now for these kind of problems, because you got like an interval sort of frequency problem, you go always find the midpoint here. So what I would do, guys, and let me just delete this carefully. I would always add another table called the midpoint, and we're going to call this one midpoint X, yeah, just to give a name. And this is frequency F. And all you got to do is firstly, well, find the midpoint over here. And to calculate midpoint, if you're not sure, if you can't see that between 160 and 164 is 162, you could instead just add these two numbers. So 160 plus 164, add them up, and then half it. And then halfway between you get this value. So do the same thing for the rest, guys, yeah? Find the midpoint for the rest of them. So the next one will be 166. Next will be 170, 174, 178, and 182. And now to work out the total weight, this just means you need to now multiply each of these values, yeah? So 12 times 162, 20 times that, and keep going. And for each case, you want to add these, yeah? So work them out and then sum them up. And when you do that, when you find the multiplication of everything and you added the total results, you should get a total weight of 10,120 grams. So that's how many all the apples weigh, yeah? Because you got, for example, you got 12 of them. On average, they're 162 grams each. Just multiply them and then sum them up. Now, is it in grams? Yeah, it's in grams. So careful, guys. Sometimes they might just try and play games with you and write kg or something. So always check out what unit you're working with. Now, next bit. So using the table above, complete the cumulative frequency table. All right, cumulative frequency just means add and go. So notice how the weight class slightly changed, yeah? For example, over here you had like 12 apples that weigh between 160 and 164. So you should write that there, which is the same. However, the next group like now is between 160 and 168. And this was 164 to 168. So what they did, they kind of included, they kind of opened the range a bit. So this means they're including as you go. So it'll be 12 plus 20. So now you have 32 apples in that way. And well, to make it easy for you guys, just add and go. So all you gotta do is add and go. So you got 32 now, add another 14. 32 plus 14 is 46. Add 7, which will give us 53. So this is kind of a bit, yep. And then add 4 and add 3. This will give us 57, and then finally 60. So this means by the end, you should have all 60 apples between the smallest weight and the biggest weight. Okay. All right, now scrolling down the part D, guys, it says on the grid, draw a cumulative frequency graph for your table. In other words, we got to be plotting this now. So the way to plot this comfortably, let's have a look at the graph. You got weights across the x-axis and you got cumulative frequency across the y's. So this means your x-axis, which will include the endpoints, yeah? So always do the endpoints. What I do, I always circle them like this, yeah? And this is going to match up with the y values of 12. So this could be your x-axis and this will be your y. And yeah, just have to plot everything, yeah? So let's do the first one. So you got 164 and 12. So this means 164. Oh god. So let's see. So, well, it's 5 across here and it's 10 blocks. So every block is a half. So every 2 blocks is 1, yeah? So that's 61, 62, 63, 164. And this is going all the way up to 12. So we got to kind of repeat this for, so this is kind of long. Let's repeat this for all, yeah? So 168 and 32, 168, 6, 7, 8. So 168 is here, guys. And that goes up to what again? 32. So 168 stretch up to 32. Anyway, I'm going to quickly do this here. So we're going to repeat this for the rest. And now to make this complete, always draw a nice curve here. So I'm going to zoom out a bit. Curve should be, oh, this is going to be hard. It's going to be, it has to be like a snaky curve, yeah? So this is a bit hard. Yeah, something like that. All right, a nice little snaky curve. Yeah, so that's it. That's just part D done. Now looking at E, yeah? So work out an estimate for the interquartile range, so the IQR. Okay, so interquartile range means the difference between the upper quartile and the lower quartile. Now to work out the upper and lower quartiles of these kind of problems, what I would do is just firstly ask myself, alright, so how many apples we all have altogether? Well, we've got 60 apples. Now lower quartile means find the first quarter. Well, that essentially means 1/4 of 60. Well, one quarter of 60 is just 15. So this means that the lower quartile is actually over here, corresponding to 165. So this is the lower quartile. And the upper quartile is 3/4 of 60. And 3/4 of 60 is just 3 times bigger than 1/4, which is now 45. So we draw a dotted line over here, corresponding to the upper quartile, and it hits there, and you just keep going all the way down. I think that's going to smack around here, what, about 171. So by the way, guys, because I'm doing a computer, it might be a bit inaccurate. I'm not completely sure, but always double check the mark scheme. But more or less, this is the kind of graph you're looking at, yeah? So yeah, so this is the upper quartile. So we write here, and that was about 171, yeah? And this was 165. And well, the interquartile range is a difference. So subtract these two values and you should get, well, 6 grams. And that's it. That's the end of this question. All right, number 11. Solve the simultaneous equations. Okay, in this case, both of these equations are linear, meaning there's no x squared or y squared terms here. Now to solve these nice and easy, my personal trick is to always multiply the top and bottom by whatever the values are in front of the x. For example, on the top half, we want to multiply the first equation by 4, and on the bottom, we want to multiply this by 7. And the reason why we do this is because we want to make it both 28x. And then when we subtract the equations, the x will go. So let's have a look here. If you do the first one, times it all by 4, you're going to get 28x minus 8y equals 4 times 21, 164. Okay. For the bottom half, multiply by 7. Again, you're going to get 28x, which is objective, plus 3 times 7 is 21y equals 77. Now here we just want to subtract these two, yeah? And doing that will get rid of the 28x. So subtracting these two, well, that becomes nothing. Minus 8, take away 21 gives us minus 29y, yeah? So be very careful with the subtraction. And then 164, take away 77 should give us 87. And then to find y, well, all you need to do is just divide 87 by minus 29. And when you do that, you should get a y result of -3. Okay, that's not bad. Now, if you get one of the values, you can easily find the other value. And what I would personally do, I would look at all the possible equations I have and just pick the easiest one, yeah? Now, for me, the easiest one is probably, and this is just me, yeah? The second one. Now, if I just replace this y value with -3, what happens here, yeah? We now have 4x, which is the same one, plus, okay, 3 times -3. That's actually -9, so it'd be -9, and then equals, well, 11. This is easy to solve now. This is just a straight up linear solving equation. Now what I would do is move -9 across, and if I move it, I'll have to add 9 across. This will leave us with 4x equals 20. And to separate 4 from the x, well, you just got to divide it. So dividing 4 across, x will equal 5. And that's it, guys. That's your two solutions. All right, number 12. So looks like we got a big pentagon, and it says that AQE and ALB are straight lines. Now ALM and PQ, so the inside part, is a hexagon with 2 angles of size y and 4 angles of size x. All right, work out the value of x. All right, so by extension, we're going to work out the values of x and y, yeah? So how should we start this? Well, first things first, let's deal with the y, because to me that looks a lot easier, because that seems to be covering the pentagon and of course the hexagon. But let's work with the pentagon. Now, every time you have shape equations like this, shape formulas, it's always important to learn certain equations, yeah? The most important one in this case, because you're dealing with interior angles, we need to firstly ask ourselves, how much does a pentagon add up to? Well, the sum of interior angles is n minus 2, so the number sides, take away 2 times 180. Now, because we're working the sum of a pentagon, yes, let's say for a pentagon, the sum of the interior angle is going to be, well, 5 take away 2, which is 3 times 180. And that should give us 540 degrees. So we know straight away that all of these angles in this regular pentagon must equal 540. And by extension, because it's regular, this means every angle here must also be the same. So all of this is technically y. Now to get y, because you've got 5 sides, divide your 540 by 5. So therefore 540 divided by 5 should give us 108 degrees. So therefore y is 108. Now this is easy. Now you've got pretty much everything. Now what we could do here is ask ourselves, alright, so now we've got a hexagon, yeah? What should all of these add up to? So again, using the sum of the interior angles, we say for a hexagon, we can now say that the sum of the interior angle of a hexagon, well, you got 6 sides. 6 take away 2 is 4 times 180, and that should give us 720 degrees. Now, just do the quick maths here. Now we have to add up all of these lots, so we're going to have x plus x plus x, which is going to be 4x, plus your 2 108s, which is 216, and it should total to 720. Now, just rearranging this carefully. If you do it carefully, you're going to have x equals, well, 720, take away 216, all of that over 4, and your answer results to 126 degrees. And that's it, guys. That's literally 4 marks for that. Alright, number 13. So solve 4x squared plus 6x minus 1 equals 0. Okay, so that's it. So first things first, when we look at this, we need to recognize straight away that this is a quadratic equation, yeah? Now for quadratic equations, there's only one, well, there's a couple ways to do it, but there's always one way we should do it. Because you're doing IGCSE and you got a calculator, use the quadratic formula, alright? If you're not sure what the quadratic formula is, it always looks like that. It's always x equals minus b plus minus the square root of b squared minus 4ac. All of that over 2a. And we just pop in the values, put in a calculator, and you're done. Now what are a, b, and c? Well, just look at the values in front of the x's and the constant. In this case, this one is always the a, this is the b, and this is the c. In other words, a is 4, b is 6, and c is minus 1. Now plug it in carefully. So you got minus b, so you got minus 6 plus minus big square root sign, and then b squared, which is 6 squared, which is 36, minus, and now when you pop in values that stuck together, wrap them around in a bracket. So you can get 4 bracket a, which is a 4, and a c, which is a minus 1. I was about to say 6. All of that over 2 times 4, which is a. Now, yeah, so literally just put this on your calculator. The first thing you guys want to do is firstly put the plus sign, yeah? And then when you get an answer, do the same thing, but delete this part and put it as a negative sign. And what happens actually is that you get 2 results. The first of it would be 0.151, because remember they wanted the 3 senior figures. And the second result would be minus 1.65. And that's it, guys. Literally as simple as that. Alright, number 14. So guys, in every single paper, you're always going to get some kind of circle theorem or circle geometry question, yeah? And I'll tell you one thing. If it looks like this, then it's such a blessing. This is actually one of the nice ones to have. But anyway, let's have a look and see what they want. Well, it says D, E, F, and G. So these 4 points are on a circle with center O. And the angle of GOE, so G to O to E is 98 degrees. Okay, so that's the middle one here. Work out the size of angle GFE. So GFE. So they're talking about working out this angle here. And we're going to call this X for now, yeah? Give a reason for each stage of your working. Alright, so this is probably the most important part, is your explanation and how clear it could be. Now what I would do is firstly ask ourselves, what can we see here? Well, the first thing I want you guys to always spot is this a 4-sided shape in a circle? Yes, it's 4-sided because it hits at 4 points in the circle. When you have something like this, you end up having something called a cyclic quadrilateral, yeah? So a cyclic quadrilateral. What that actually means, guys, is that from each corner, so let's say, let's call this D because this is D. We can say that, let's say, the 2 opposite ends, so F and D must add up to 180. So X plus D equals 180. And the other end, let's say G and E, must add up to 180 as well. So, okay, so this is actually the first property. Now, there's also a second property, and this is this kind of shape. So let me just change color. So you got this kind of shape. So D, G, O, E. So you can kind of see it's kind of like a little ship or something, a little spaceship there. And what we say here is that any angle in the center of the circle is twice the angle as circumference. Yeah. So if you got this kind of shape, this value is always double what this should have been. So in other words, D is going to be half of that. So we say D is 98 divided by 2. And that should give us 49 degrees, guys. And now we're done. And now again, we look at the shape. And remember earlier, we said we got a cyclic quadrilateral, right? This means that X plus D must equal 180. We know D is 49. So now we got X plus 49 equals 180. Just rearrange this, subtract 49, and X ends up being 131 degrees. And you're done. That's all you need to do. All right, number 15. So write 2 over x minus 1 over x plus 3 as a single fraction and then simplify it, yeah? All right, so to make anything to a fraction, when you add or subtract, the first thing that should come up in your head is that they must have common denominators. In other words, the bottom needs to be the same. Now, if we're looking at both of them, we've got an x and we've got an x plus 3. The easiest way to do this is to just multiply the left fraction up and down by x plus 3 and the fraction on the right up and down by x. Now, whatever you guys do, never add a plus 3 on this because that's just going to mess it up. You don't want to be messing up this fraction, and it doesn't make sense when you do that. So in this case, times it up and down by x plus 3, this is just going to look nice. It'll just be 2 bracket x plus 3 over x bracket x plus 3. And just copy the next bit. Again, times up and down by x, so 1 times x is x. X plus 3 times x, well, just copy out the same one. So x bracket x plus 3. Now, a little tip, guys, yeah? When it comes to the denominator, the bottom bit, don't bother expanding it, yeah? Because there's no point. The trick is that you want to try and simplify it if you can. Now, because we've kind of linked it up, all we do now is just, well, subtract the top half. So 2x times 3, which is, I'm just going to do it quick, yeah? This is going to be 2x plus 6 minus x, all of that over x bracket x plus 3. And just simplifying this, you should get, take away x, is just x. So it'll be x plus 6 over x bracket x plus 3. And that's it. You're done. Now for part B, all right, simplify fully this kind of weird quadratic. So it's kind of, it looks like a difference of 2 squares to me. You got a square, take away another square, over a regular quadratic with an a value, which is annoyingly a 3. So to do this, first things first, we need to know something called dots, yeah? When you see a quadratic in this form with no x in the middle, it's likely going to be a difference of 2 squares. Now to factorize it easily, my tip is to always think of it this way, yeah? First, you always do a double bracket and ask yourself, all right, what's the square root of 9x squared? It's just 3x. So put 3x on both. What's the square root of 4? It's 2. So put 2 on both and then stick in a plus minus. And you're done here, okay? I would explain this, but just keep it like that for now, yeah? So next, all over. And now we have to ask ourselves, how do you factorize this thing here? Well, my trick is to just use a quadratic formula, or there's another smart thing. Because you're going to simplify this, you know the bottom is going to include either a 3x plus 2 or 3x minus 2. And so what I will do a double bracket, and then put a 3x here and an x. Why? Because 3x times x gives us 3x squared. Now we need 2 numbers that multiply to make 10. We know one of them is going to be 2 because this is just an exam technique, guys, yeah? They're always going to do this. The 2 numbers that multiply to make 10 would be 2 and 5. Now, where do we put it? Well, I already know that this one's going to be a 2 here because it has to cancel with the top. And this must be a 5. Now, how do we get minus 17x? Well, here's a trick. Let's suppose we multiply this out, yeah? 3x times 5 is 15x. And 2 times x is 2x. Well, to get negative 17x, this has to be minus 15 minus 2. So, of course, it has to be 2 minuses. And then you're done. And therefore, now we can just simplify this. So, changing pen. This means that 3x minus 2 cancels with 3x minus 2. Meaning you're left with the top, which is 3x plus 2. So, you don't need brackets anymore. over x minus 5. And that's it, guys. This question is done. All right, number 16. Work out the area of triangle PQR. Okay, so clear and objective. Let's do it. Now, to work out the area of any triangle, well, there's always one formula which we know, which is half times base times height. However, this only works if your triangle is right angled, yeah? Of course, this is just a random triangle. So there's actually another formula which you're taught to learn, which is half AB sine C. Well, in this case, A and B are lengths between an angle C. In other words, we look at this triangle, we ask ourselves, all right, here's our A, here's our B, and we need an angle between it. Well, the only angle is Q, so this would be our C. Now, what they want us to do here is actually to do a couple other things before working out the area of triangle. And that is to work out the angle C first, and probably R as well, to get C. And to do that, well, we need to ask ourselves, for any triangle, there's only two things you can do. Either the sine rule or cosine rule. Thankfully, you're given this in the front of the booklet. I can't remember if it's given for the new 1H, 2H, even though I do it 100 times. But my advice is just memorize the formulas, because if you memorize them, you know that you're going to use them. If you don't memorize them, you might even forget how to use them. So let's have a look. So first things first, what I'm going to do is ask ourselves, like, let's see if we can use the sine rule, yeah? Now the sine rule tells us that we need a matching pair of length and angle, yeah? Well, we got 78 degrees, which is opposite 18.5. And well, 12.7 will have to be opposite angle R, okay? So according to the formula, we can say that sine R, so sine of the angle over its opposite length, must equal sine of P, in other words, sine of 78 over its opposite length, 18.5. So this is the sine rule, guys, yeah? So always do opposite pairs. Now what we're doing here, we're trying to find the angle of R, yeah? So let's go rearrange and make sine R the subject. So to do that, I would times 12.7 across. So sine R equals all of those lot over whatever that was times 12.7. Now what I want you guys to do is literally just smash this all in the calculator, sign like everything on the right side. When you do that, I want you to then separate sine from R. So I want you to sine inverse. So sine -1, whatever your answer in your calculator is. And when you do that, you should get an angle of, what am I doing? An angle of 42.1817 ... degrees. So you get something like that, yeah? Now, when you do this, okay, so when you do this, we now find angle R. And we can easily find angle Q or C. And that is because we're working with a triangle, we know all angles in a triangle always adds up to 180. So my advice now, we can just use this angle, add it to 78. So this angle, let's say 42.1817 plus, what was it again? 78. And wherever this is, you're going to subtract it from 180. And doing that, you're going to get an angle of, let's say, 59.8183 ... degrees. Now, what I'm doing here, guys, you probably noticed that I'm always keeping the answers in extended form, yeah? Try not to simplify yet, because if you do, it might screw up your final answer. And I'm telling you, there's a good chance that you could get a completely, like, you can be right, but you might be off by 1 or 2 values and you can get it wrong. So always don't round it until the final answer. So okay, so let's update our triangle for a second, yeah? So now we got this angle C, which was, what did I just write? 59.8183 degrees. And now using the area of a triangle, half AB sine C, it'll be half times A or B, so half times these two lengths. So we can say, all right, let me change the color pen. The area is going to be half times 12.7 times 18.5 sine that angle here, 59.8183. And you're done. And when you put this in exactly as it is, you're going to get a couple answers. You might get 101.54 ... If you do this, remember to round it to 3 sig figs, yeah? So that shoots up to 102. You know what? I checked the mark scheme earlier and they also accept 101. So if you get 101 or 102, you're fine. But other than that, we're done. And I hope this video helped you guys. If you've enjoyed it, please give me a like. Because as I said earlier, if you like my videos, they actually end up appearing in the search bar. So YouTube will pick it up and put about other people. Of course, only do that if you guys actually liked my video. Yeah? But other than that, thank you guys for watching. You know, I appreciate you guys for always being here. And other than that, I'll see you guys in the next part. Ciao. So for number 17, they want us to rationalize the denominator of this fraction here. And when they say rationalize the denominator, they mean change the surd on the bottom half into a whole number. Now guys, there's actually a little hack over here. You could actually put this all in your calculator, and when you do so, you'll get the direct answer. Now unfortunately, you need to show your working, otherwise you can't do that. But that's like a little safeguard, so you know what kind of result you should be getting. Now to rationalize this easily, you always got times up and down by what the bottom is. In this case, we got times up and down by root 2 over root 2. Now what happens when we do this? Well, on the top half, you can have root 2 times both of these terms. 6 times root 2 is 6 root 2. And then root 10 times root 2 is just root 20. Alright, so far so good. Now all over, and when you do root 2 times root 2, when you times two of the same surds, you just get a whole version of it. So just a whole 2. You could also write root 4, but we know what square root 4 is. It's 2 anyway. Now it looks like we're almost there. Now what we're going to do, we're going to go ahead and try and tie this up, yeah? So first things first, I would firstly try and simplify root 20. Now to break down root 20, what you could do is use the prime factorization tree. That is, just put 2 legs coming down and put 2 numbers that multiply to make 20. Well, we know root 20 can be broken down into root 2 and root 10. And then root 10 can be broken down into root 2 and root 5. Now, that's really it. And at this stage, you just collect all the roots. So what I always do, I circle the last legs and I say to myself, all right, root 2 and a root 2 gives you a whole 2. And you're left with a root 5. And that's what square root 20 is the same as. And by the way, I'm not 100% sure, but you can probably get away just writing root 20 in your calculator and it will give you this answer as well. Now, let's put this all back into the final equation. So updating our equation over here, we got 6 root 2 plus 2 root 5 all over 2. And well, if you're dividing both of these by 2, 6 over 2 is 3, so you get 3 root 2 plus, and then 2 root 5 over 2 is just root 5. 2's cancel out. And that's it, guys. This is your final answer. Alright, number 18. So a particle moves along a straight line. The fixed point O lies on this line. The displacement, in other words, the distance or vector distance of the particle from this origin at time t seconds, where t is going to be 1 or more, is s meters. So we're saying here that it's so far traveled s meters after some period of time, where this equation can be modeled by this. So the displacement equals 3 plus 1 over t. At time t seconds, the velocity of the particle is v meters per second. Find an expression of v in terms of t. Alright, so for this kind of question, all you're going to have to do now is literally differentiate s and you get v. So if you guys are not sure, this is the process, yeah? You have a displacement s. If you differentiate respect to time, you're going to get velocity. And if you differentiate velocity respect to time, you get acceleration. This is kind of like a typical physics model, but we use this in differentiation as well. Now, the main idea is, how do we differentiate this equation? Well, you can't differentiate 1 over t like that because you need to change it to index form. Now, we always rewrite s, in this case, as 3 plus. Well, 1 over t is just the same as t to the negative 1. If you guys are not sure, when something's to the power of a negative, it means it's reciprocal. So t to negative 1 is 1 over t. If it was t to negative 2, it will be 1 over t squared, and so on. So in this case, we're going to differentiate this equation here. To differentiate, we write ds over dt equals, and then differentiate constant, you get 0. Differentiate t to negative 1, well, you drop negative 1 down, so it'll be minus t, and subtract the power by 1. Now be careful, guys. A lot of people might be tempted to write 0, but minus 1 take away 1 is actually minus 2, okay? And therefore, this is your answer. So the answer is minus t to the negative 2. Now, they might be picky. They might want you to rewrite this in this kind of notation, yeah? So t to negative 2 is the same as 1 over t squared. Either way, I think both is fine. And that's it, guys. This is your answer. Now, B, find the acceleration of the particle at time 6 seconds. All right, so to find the acceleration, we have to differentiate one more time. So let's differentiate this equation here, yeah? So we can say, all right, so yeah, let's give this a name. So this was velocity. So we say dv over dt, which will give us our acceleration now. So differentiating this one, you drop minus 2 down, you get plus 2t. Subtract this power by 1, you get minus 3. Okay, and again, this can be rewritten as 2 over t cubed. Now they're saying find the acceleration of the particle at 6 seconds. So in other words, in t6. So we say the acceleration is 2 over 6 cubed. And put that in a calculator, guys, and you should get 2 over 216. And this is the same as 1 over 108. So yeah, I think this should be your final answer, and that's it. Alright, number 19. So the diagram shows a container made from a cylinder and a cone. So here's our cylinder and here's our cone. The container has a vertical axis of symmetry. So I think when they say that, all they want to say is that if you just put like a needle or something in, or a line, it's like symmetrical around that. I don't know, that's what I personally understood from it. Now, looking at the shapes, so we've got cylinder and a cone. The cylinder has a height of 20 and a radius of 15. And the cone has a height of 18 and also a base radius of 15. There are 9 liters of water in the container. Okay, so notice how they use liters here. What this is trying to say is that for every 1 liter, and we need to know this relationship, you get 1000 centimeter cubed as its equivalence, yeah? So this is actually an identical relationship. Okay, so I think that's kind of tricky. So they want to know that 9 liters is therefore 9000 centimeter cubed. Okay, cool. So work out the height of the surface of the water in the container above the vertex of the cone. Okay, so the best way to understand how to solve this question is to firstly figure out what's the volume of both these shapes. Because we know there's 9 liters inside. It doesn't cover everything, but it goes up to some height. So if it helps, what I would do, I'm going to just put a little diagram here. So let's just imagine 9 liters goes up to here, yeah? And it's covering this entire area. And we know that this is some height that they want us to work out. So this could be the height of the water in the container. Okay, if we can figure out what that volume of water is, then we're good. And the best way to do that, figure out the volume of both this shape and then start subtracting until we get the answer. So let's do it like that. Now first things first, what is the volume of a cone and volume of a cylinder? So in this case, the volume of the cylinder, so I'm just going to label this part here, is pi r squared h, where r is the radius, h is the height. And because we've got everything, it's just pi times 15 squared. So 15 squared times your height of 20. And this simplifies to 4500 pi. So always just work out in pi form, yeah? Try not to simplify yet. And as for the volume of the cone, this one's literally also given, and it's a third pi r squared h. So it's actually 1/3 of the cylinder. Now the only difference here is that the radius is actually the same, but the height is different. So the value is going to be 1/3 times pi times 15 squared times 18, and this should give us 1350 pi. Again, always leave your answers in pi form, yeah? It's more accurate and it's just easier to look at. Now, what's next? Okay, so now with these volumes, and we know the fact that there is 9 liters of water in the container, which by the way, guys, is the same as 9000 centimeter cube, so that is 9 liters. What I would do is firstly, I would subtract 9000 away from the cone part and see how much water is actually left. So we can say that 9000 minus 1350 pi should give us an amount of 4758.8 centimeter cube left. So that's how much water is left, and that's going to be the amount left in the upper part, yeah? So this region here. So this is how much water is left. Now, at this stage, we're going to ask ourselves, okay, how much percentage of this water is occupied in this cylinder here? Because if we can work out the percentage of it, then we can use that percentage to multiply against 20 to figure out how high the water actually was raised. So I always redraw these things, yeah? So I'm going to redraw the cylinder here in 2D form. Let's say this is the area that's currently occupied. That's equal to this value here. And we know that the container itself has an area of a volume of 4500 pi. So 4500 pi. Now to figure out how much water is actually occupying this container, we just got to divide them. So it's going to be, therefore, 4758.8 over 4500 pi. And this should give us some kind of small number. If you do it correctly, you should get an answer about 0.3366 and so on. So what it's trying to say here is that this water is occupying about 33.66% of its height. So all we do now, using the scale factor, we're going to multiply against 20 and find out how high it is. So taking this of 20, so we say therefore that amount times 20 should give us about 6.73 centimeters, guys. So that's how high the water was raised in this pod container. So this is 6.73. Therefore, the whole height, so HW, will be this amount plus 18. So therefore, we say the height of the water was 18 plus 6.73 centimeters. And again, they wanted to 3 significant figures, guys. So that's about 24.7 centimeters. And that's it. Whew, man, this question was a bit tricky, wasn't it? Let me know your thoughts about this question so far, guys. You know, let me know if you got any doubts on any part of the calculation. It is kind of intense, I'm not gonna lie. But anyway, let's move on. All right, number 20. So there are 9 counters in a bag. There is a number on each counter. All right, so we've got 9 counters here. 3 of them are 2s and 6 and the rest of them are 5. So that's 6 of them. Okay, oh thank God, so it's not a mixture of numbers. Now Lev takes at random 3 counters from the bag. He adds together the numbers on his 3 counters to get his total. Calculate the probability that his total is an odd number. Okay, so for these kind of questions, let's just do what they say here, and pick 3 counters and see all possible combinations to get odd, yeah? Now, if I just start from the top, to get an odd number, we should always pick 2 evens and an odd. Or 2 odds and an even. I think. Nope. 2 evens and an odd. So, for example, our combinations could be, you get 2, another 2, and then that makes 4, and a 5, and that makes 9. That's an odd number. You could also do 5, 5, 5. Yep, that's an odd number. What else do we have? 2, 5, that's even, that doesn't count. So we keep testing it. 2, 2, 2, that's even. Yeah, I think that's it. There's only 2 possibilities. Perfect. Now all you want to do from these possibilities, stick in a P sign for probability and ask yourself, what is the probability of taking a 2 first? Well, let's do it over here, yeah? I'm going to rub this out quickly. So probability of taking the 2 first is going to be, well, we've got 9 counters. You've got 3 2s first, so it'll be 3 out of 9. Now, probability of taking the second 2, well, we've now got 8 counters left, and 2's already been taken, so you've got 2 left. And then now you've got 7 counters. What's the probability of taking a 5? Well, you've got 6 of them. So this would be the first set, and then you can easily work out after. And you do the same for 5s. So again, we ask ourselves, what is the probability of taking a 5 first? So you got 9 counters, and you got 6 of them. So 6 out of 9. Probability of taking another 5 is going to be 5 out of 8. And probability of taking, what is it? A third 5 would be 4 out of 7. Okay, because that's how many you got left. And yeah, that's it, guys. We just work them out and we get a result. So if you work them out independently, this would be 1 out of 14. And the bottom one would be 5 out of 21. So just use your calculator, guys, yeah? So now we ask ourselves, is there any other probabilities we can do? Yes, there is actually. We can look at the first one and realize we can do this in different order. For example, we could have picked a 5 first and then a 2 and a 2. Or we could have picked a 5 in the middle. So 2 first, a 5, then a 2. So actually, and it turns out if you do in a different order, you're going to get the same result, which is also 1 out of 14. And again, 1 out of 14, because you got pretty much the same set. So essentially, you got 4 probabilities to work out with. It doesn't work for this one because you can pick 5 in any order and the output is the same. In this case, you have a different order. And yeah, that's it, guys. So now you got all your results. We just want to add them all up. Now, if you add up all of these 4 probabilities, you got 1/14 plus 5 21s plus another 14th and another 14th. You should get a total probability of 19/42. And yeah, that's it, guys. This is your answer. And here we go, guys. Number 21. And this is the last question of the paper. So let's do this. So it says that f is the function such that fx equals 3 minus 2x. All right, so this is your function defined. Find f at the point minus 4. So in other words, when x equals minus 4. So let's go ahead and do it. So all they want us to do here is replace x with minus 4. So it's going to be 3 take away 2 times minus 4. And if you put this all in the calculator, you're going to get an 11. And that's it. That's A done. B, express the inverse function f to the negative 1 in the form of f to the negative 1x. Yeah, you know, I never really understand why they write like that. But all they're saying here is just compute the inverse function, yeah, of f. Now, to get the inverse function, there's a nice little trick to do this. I always start like this. I say, okay, let x equals fy, so you do things in reverse. And essentially, you replace fx with fy, so all the x's become y. So replacing this with y, you get 3 minus 2y. Now, all you want to do here is literally rearrange this to make y the subject. So again, because all of this equals x, in other words equals x, I'm just going to deal with this part. So 3 minus 2y equals x. I'm going to rearrange to make y the subject, and then you're done. So to do it step by step, I would firstly minus 3 across. So it'd be minus 2y equals x minus 3. And then I'll divide this by minus 2 to get y on its own. So y equals x over 3 minus 2. And if this result looks kind of weird, you can tidy up by just flipping the order. So this is the same as 3 take away x over plus 2. That's it. So the negative literally just flips the order. And that's your answer. 3 minus x over 2. I'm sure this is also right because it's equivalent. But it's better to get something that looks nicer. Alright, so guys, next part. So g is the function such that gx equals x squared minus 5. Alright, so that's a new function. We had fx, now we got gx. Solve the equation, gfx equals ffx. Man, show clear algebraic working. Alright, what does this mean? So gfx, so this means that f has gone inside g. In other words, this function, this x squared, all this x is being replaced with this entire f function. So we say, alright, that's your f, that's your g. So g fx is basically, instead of x squared, it's going to be the f function, 3 minus 2x. Now it's squared, take away 5. As for ffx, well, that's, as I say, that's f in f. So you put in this function inside the x. So let's copy out 3 minus 2 part for a second, yeah? This is 3 minus 2, and inside the x, you're going to put 3 minus 2x. Yeah, it's a bit weird, but that's how it is, yeah? And now apparently, both of them are equal, so we make them equate to each other. So before I equate them, how about we go ahead and simplify the expressions, yeah? So the top half, like this is a double bracket. So this is essentially 3 minus 2x times 3 minus 2x, then take away 5, okay? And evaluating this isn't too bad. So we just do 3 times 3, 3 times minus 2x, minus 2x times 3, and minus 2x times minus 2x. And then take away 5. And doing that, well, you're going to get a 9. 3 times minus 2x is minus 6x. And you get another minus 6x, so it's minus 12x. Minus 2x times minus 2x is plus 4x squared. And then you subtract 5. And then just tidying up the order, I always do the quadratic first, yeah? So 4x squared goes first, minus 12x, and then 9 take away 5 is plus 4. That's it. So that's the gfx tidied up. As for the other one, ffx, well, do the same thing, guys, yeah? So for ffx, oh, you just expand in the bracket. It'll be 3 take away, well, you got minus 2 times 3 is minus 6. Minus 2 times minus 2x is plus 4x. And tidying this up, again, I do this in order, so 4x goes first. 3 take away 6 is minus 3. And that's the other one done. And lastly, again, according to the equation, it says solve the equation when they're equal to each other. So let's equate the quadratic with the linear term. We're going to get 4x squared minus 12x plus 4 equals 4x minus 3. And now because you're solving a quadratic equation, you're going to move everything to the left side. So combine terms and make it equal to 0. Okay, so make this equal to 0. We're going to minus 4x and add 3 across. If you do that, you're going to have minus 12x, take away 4x is minus 16x, plus 4, add 3 is plus 7. Alright, so it looks to me like we're almost getting to the end here, yeah? Now, what can we do? So, if we solve this quadratic, I think we're done actually. Is that what we're done? Yes, we're done. Alright, to solve this, I would just use the quadratic formula because it's quick and easy. Now to use the quadratic formula, again, just find your A, B's and C's. 4 is your A, minus 16 is your B, and plus 7 is your C. And the quadratic formula, guys, is always x equals minus b plus minus square root of b squared minus 4ac all over 2a. And yeah, putting all of this in. So let's see if I can do this in that space. X is going to equal minus b, so b plus 16 plus minus square root 16 squared. I'm not going to bother doing that. Minus 16 squared minus 4 times a times c, so 4, 4, 7. Again, wrap them in a bracket, yeah? All over 2 times 4, which is 8. So now put everything in your calculator. For the plus minus bit, first you write a plus sign because you can't do this symbol. Get an answer and then repeat it with a minus sign. Or just go back and change the sign to a minus. And when you do it, you'll get 2 answers. The first answer will be 7 over 2. And the second answer should be 1 over 2. So in other words, 3.5 or 0.5. And yeah, guys, we are done. And yeah, thank you guys for tuning into my video. I hope these questions have been helpful. If they have, please leave a comment and suggest me any new papers you want to do. After this paper, I'll probably just work on a more recent papers. But if you guys got anything else you want me to help you with, again, let me know in the comments. And yeah, we'll keep in touch, guys. But other than that, stay blessed, stay safe from the coronavirus, and I shall see you guys next time. Ciao. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go into my channel page, hit the subscribe button and hit the bell for more notifications. And if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.